Okay, so I'm going to do a problem out of Chapter 7, number 18. And so this is what it says. I'm not going to read the whole thing, but we're basically looking at the rents versus mortgages for these cities. And we're supposed to do four things. First, develop a scatter chart for the data, and then do a simple regression model and see if it appears appropriate. And then we're actually supposed to do a regression model and develop an estimated regression equation. And then we're going to construct plots of residuals. So this is basically a regression in the data analysis. And then we're supposed to determine if it appears to be the appropriate type of model. And then we're supposed to do a quadratic equation regression analysis. And then that's going to be basically we're going to have a, instead of just rent, we're going to have to look at a rent squared to get the quadratic part. And then we're going to determine if we like the linear regression or the quadratic regression better. And then we're going to actually overlay the linear on top of the other. The quadratic. So first, let's go ahead and do the straight scatter plot. Well, that's what that is, so let's go ahead and choose that. So looking at this, you know, it's moving up and to the right. It's positive. It's positively correlated. But, you know, is it very good? Let's do a trend line just to kind of get an idea. So, you know, it's an R squared of 0.7561, not super good. And we see now with the trend line there, it has kind of some variability there. All right, so now instead, let's do a regression analysis like it says to do in part B. And so we'll go to regression. Now this is going to be our Y. This then will be our X. We have labels there. Let's put it into B. We want residuals, so that works. And so this is going to be our residuals and our equation. So we're going to get our equation from right here. So that gives us y equals, and then we have a negative 197.958, and then plus a 1.0699x, and that's going to be our regression line. Okay, and let's go ahead and highlight that, kind of make it a thing. So no, this is already we had 197.58, well, 0.6, and then the 10699. We already had that here, but we didn't have this residual plot. And the residual plot kind of shows that we're really far away from zero. You know, we have 2 up here above 0, 1 almost down here to 200, some others, you know, scattered all over. So to me, it doesn't look like a good one, really, especially keying in on those and those. Okay, so I would say it's not super good. And so then what we're supposed to do is do the quadratic. Well, to get the quadratic, we're actually going to have to do rent squared, and so we just have equals that value squared, and then we'll just copy that by Control D. And now what we can do is we can do a regression analysis on the quadratic stuff. So we do regression. Now our y still is going to be that, but our x, we're going to have 2 because we have the quadratic now. Let's put this in a C, and we need residuals again. So we get this, and we have 2 residual plots for the plane and the quadratic part, and we also have our quadratic equation. So that's going to be y equals, and that's 3965.633, and then we have minus 8.26062x plus 0.005131x squared. And so that's our quadratic equation. Okay. Now, if we look at these, now remember those endpoints were the ones I was kind of concerned about, plus this one, and that was close to like 200. Now we're down to 100. And these are, you know, up and down above the 0, and it looks a lot better. So it's kind of closer all around. It's a lot better. It's, you know, much closer to that 0 point, which is where we want to be. We want to have the smallest residuals possible. So between that and one, it's almost to 200 and up, and these are higher than this, and they're not balanced on both sides. I would say the quadratic looks to be the best. Now, what we're supposed to kind of do now is to do an overlay. And so basically what we're going to do is we're going to overlay it here. And oops. Let's see. So we've done this. Let's go ahead, because I'm going to try to plot it again. So we'll have this and this, and we'll do insert, and we'll do a new graph. And hopefully when I do it, we'll get the overlay. Trend line. We do a linear first, I guess it won't matter. So we have that. And then, so let's get out of that. Now let's format trend line and see if it'll let us do the polynomial, which it does, but then it gets rid of our other ones. So let's say we save that. Doesn't matter where. Now let's see if we can go back and format that trend line and put a linear also. Well, it's not going to let us do it. But no fear. I have done it before. It just for some reason doesn't always work for me. And so let's go ahead and delete that and just paste this one in. And that's sometimes what you'll find out too. You'll get it and put it in, and the next one doesn't go in, and so it varies. Excel sometimes treats me nice, sometimes not. And so we get the two trend lines. The quadratic is the curved one, and that's the equation of the line, which we found over here, basically. And then the linear one, which we found in the linear regression analysis, is that one. And we can see that really that quadratic looks a lot better. It's fitting more of the data points. We have less, points way out on each side for that linear like we have on the linear. The quadratic looks a lot better. And so in this case, I would say, the quadratic is the way to go. And not only was it the residuals look better, but the equation looked better as far as fitting on the curve when you actually draw that graph here. Alright, so that hopefully will help you with a problem like 7.18, and I'll do others later.